Hello again. Now that we have our ALU built on this part of the board, we can proceed and build the remaining registers that are still missing. We have on the top here 3 registers. This is the A register, which is connected to the output decoder. We have the B register on these red LEDs connected to the ALU, and this other register here, which will be our stack pointer register on the yellow LEDs. And under here we'll build 3 more registers, and 2 of them will be exact copies of these above, based on the 74HCT377 and 74HCT245 bus transceiver. We'll have 2 of these here, which will be then register C and D, general purpose registers. And on this part of the board we'll build the instruction register, which is a little bit different from the general purpose register, because these registers, they will be based on the 74LS173, 2 of them, because this register here, the 74LS173, is just 4 bits, and we won't need any bus transceiver because we will only be reading from the bus. The instruction register takes the data from the bus, latches it in, and then outputs to the instruction decoder or the control logic that we'll build later on. There's no need to feed back the instruction to the bus. And the reason that we're using the 74LS173 instead of the 377 is because it has the ability to clear its contents, and we'll need that because we'll need a means to reset the computer, and the only way to do that is to reset the instruction. And so we'll need a way to write zeros to the register upon turning the computer on. That's why we are not using the 74HCT377, because it lacks a clear pin. So that's it. The schematics of these registers is pretty straightforward, so I don't think I'll be presenting them. I'll just leave the link to the schematics. There's nothing else to add than what I already said now. So let's get on to the build. We now have finally finished the registers that were missing, the C and D registers, general purpose registers, and the instruction register. So let's just test this just for consistency real quick. I've hooked the control wires all to receive, and all of the registers will be synchronized. They will be latching the same values from the bus, so that we can see if all of them are working properly. So here's the first one. And finally the 8th bit. Excellent. So all of them are in the correct order. And as I said, the instruction register, we should be able to clear it just with one of the control lines here. So if I just pull this clear high, yep. We can now try to transfer data between these registers here. For example, let's try to take the value that is on the D register and transfer to the instruction register. So we'll change here on the lines to the register D output. So we should put its contents on the bus, and instruction register in, and then post the clock. And that's it. We have the value latched here. And we can also try to move value from register C to register D by making register C out and register D in. So we take register C out, register D in, and then pulse the clock. Yep. So great, we have our working remaining registers just down the ALU module. Thanks for watching, and see you in the next video.